lorry is driven between London and Newcastle. In a simple model, the cost of the journey £C when the lorry is driven at a steady speed of V kilometers per hour is cost is equals to 1,500 over V plus 2V over 11 plus 60. So we have here, that's for London there, and that's Newcastle there. And of course, we have the lorry in the middle. So the lorry is driven between London and Newcastle. Find, according to this model, the value of V that minimizes the cost of the journey. When you want to talk of minimize, you differentiate dC over dV, cost versus speed in kilometers. So to minimize, you differentiate dC over dV and make it equals to 0. And then you can solve it. So let's go ahead and do that. So to differentiate this, we have to take the V to the top. This is like V to the power 1. So we will write it as C is equals to 1,500 V to the power minus 1 plus 2 over 11 V to the power 1 plus 60. Now, differential of the cost over V. When you differentiate, you subtract 1 from the power, and then you multiply by the power. So that would be minus 1 is multiplied by the power times 1,500 V to the power minus 1 minus 1. You subtract 1 from the power. Plus 2 over 11 times, when you differentiate V to the power 1, V to the power 1 minus 1. Plus, when you differentiate 60, you get 0. So we simplify now. dC over dV is equals to minus 1,500 V to the minus 2 plus 2 over 11. You can write it as minus 1,500 divided by V squared plus 2 over 11. So that's our dC over dV. So to get the value of V that minimizes, we want to have dC over dV equals to 0. And we solve it. So we have minus 1,500 over V squared plus 2 over 11 is equals to 0. How do we solve that? If we take 1,500 over V squared to the other side, to the right-hand side, so this goes to the right-hand side. So have on the left-hand side, we have 2 over 11 is equals to 1,500 over V squared. When it goes to the right, it becomes positive. Now we can cross multiply. Cross multiply. So got 2V squared V squared equals to 11 times 1,500. And you can work that out to get V to be equals to Square root of 8250, which will gives you 90.8 kilometers per hour. So that's the value of the 90.8 kilometers per hour. And that's for part 1, done. For part 2, it says the minimum cost of the journey. So we want to find C. So we will write C is equals to 1,500 divided by V, which we found V to be from part 1. V is 90.8 kilometers per hour plus 2 over 11 times 90.8 plus 60. And when you put that in your calculator, you will get C to be approximately 93.03. And the symbol, of course, is pounds. As you can see, it says at the top there, solutions based entirely on graphical or numerical methods are not acceptable. That means if you just draw a graph and get the answer and write it down, they wouldn't accept it. So but you can use your graphics calculator. You've paid a lot of money for it. So you will put 1,500. Instead of V, you put X plus 2 over 11. Instead of V, you will put X plus 60. And then you will press plus and minus to zoom in. You will get the graph like this on the right-hand side. And you will press G solve on the calculator, G solve. And you will look for minimum. And it will tell you the minimum is when X is 90.8. You can see I've circled it 90.8. And the value is 93, which is there. So with this graphics calculator, you can get the answer before you start doing the question. And this question is 6 marks. So question 8, part A is 6 marks. With the calculator, within 30 seconds, you get the 2 answers that they want. And then you can go and differentiate and show it so that you can get the full mark in the exams. Okay, let's go to the next part. Part B. Proof by using d squared c over dv squared that the cost is minimized at the speed found in A part 1. So we want to differentiate the second time. So we will take this v squared to the top and we will write it as minus 1,500 v to the power minus 2 plus 2 over 11. So that's what we want to differentiate. So to get d squared c over dv squared, multiply by the power. The power is minus 2 times minus 1,500 v to the subtract 1 from the power, v to the minus 2 minus 1. And then when you differentiate 2 over 11, you get 0. So simplify that. Minus 2 times minus 1,500, it gives you 3,000 v to the minus 3, which is the same as 3,000 all over v cubed. Now, if we know v is 90.8, let's sub that in there. So that will give us 3,000 divided by 90.8 cube, which would give us 0.004. And 0.004 is bigger than 0. So what we conclude is that d squared c over dv squared at 90.8 is bigger than 0. So therefore, it is a minimum point. That's how you conclude it. And if you want to see it visually, you look on the graph, you will see that point there is a minimum point there. That point there is a minimum point. Visually, that's what you see on the graph. And that's how you show it by differentiating the second time. Part C, state one limitation of this model. The speed cannot be the same throughout the journey. Just throughout the journey, the whole journey, the speed cannot be kept constant. So you cannot drive at the same speed. The speed cannot be kept constant throughout the whole journey. The speed will be changing as you're driving throughout the journey from London to Newcastle. So if you think about it, this lorry is going to move from London to Newcastle, and it will be moving along the motorway like that. See the motorway below. There will be traffic where you'll be slowing down. So when there's traffic, the lorry will slow down. And there are other points where it will go faster. So you cannot do the 70 miles per hour throughout, or 40 miles per hour like cruising throughout. So things will change. So the speed is not the same throughout the journey. So for this question, it's a total of 7 marks. So it's very important you understand the words. The words are minimize. That means whenever I see minimize or maximize, make sure you differentiate. Find the cost, you substitute in, and then you would get the cost. You differentiate the second time is to determine whether it's a maximum point or a minimum point. So those are the important things for this question. So I hope that makes sense, and I hope it helps you with this question. So I hope this question helps you, and especially for Adam, you asked me to make a video for this question for you. So I hope you understand it now, that when you see minimum, differentiate. When you hear the word maximum, you differentiate. Put it equals to 0, solve it, and good luck with your other exams. And thank you for asking for help for this kind of question. Well done, Adam, and good luck with the next test or next exam.